Okay, today I have the pleasure of interviewing Ilya Sutskever, who is the co-founder and chief scientist of OpenAI. Ilya, welcome to the Lunar Society.
Thank you. Happy to be here.
First question, and no humility allowed. There's many scientists, or maybe not that many scientists, who will make a big breakthrough in their field. There's far fewer scientists who will make multiple independent breakthroughs that define their field throughout their career. What is the difference? What distinguishes you from other researchers? Why have you been able to make multiple breakthroughs in your field?
Well, thank you for the kind words. It's hard to answer that question. I mean, I tried really hard. I gave it everything I got. And that worked so far. I think that's all there is to it.
Got it. What's the explanation for why there aren't more illicit uses of GPT? Why aren't more foreign governments using it to spread propaganda or scam grandmothers or something?
I mean, maybe they haven't really gotten to do it a lot. But it also wouldn't surprise me if some of it was going on right now. Certainly, I imagine they'd be taking some of the open source models and trying to use them for that purpose. I would expect this would be something they'd be interested in the future.
It's technically possible. They just haven't thought about it enough.
Or haven't done it at scale using their technology. Or maybe it's happening, but just don't know it.
Would you be able to track it if it was happening?
I think large scale tracking is possible. Yes. I mean, it requires a small special operation. It's possible.
Mm-hmm. Now, there's some window in which AI is very economically valuable on the scale of airplanes, let's say, but we haven't reached AGI yet. How big is that window?
I mean, I think this window, it's hard to give you a precise answer, but it's definitely going to be a good multi-year window. It's also a question of definition, because AI, before it becomes AGI, is going to be increasingly more valuable year after year. I'd say in an exponential way. So in some sense, it may feel like, especially in hindsight, it may feel like there was only 1 year or 2 years because those 2 years were larger than the previous years. But I would say that already last year, there've been a fair amount of economic value produced by AI. And next year is going to be larger and larger after that. So I think that there's going to be a good multi-year chunk of time where that's going to be true. I would say from now till AGI, pretty much.
Okay. Well, because I'm curious if there's a startup that's using your models, right? At some point, if you have AGI, there's only one business in the world, right? It's OpenAI. How much window do they have? Does any business have where they're actually producing something that AGI can't produce?
Yeah, well, I mean, it's the same question as asking how long until AGI.
Yeah.
I think it's a hard question to answer. I mean, I hesitate to give you a number. Also because there is this thing effect where people who are optimistic people who are working on the technology tend to underestimate the time it takes to get there. But I think that the way I ground myself is by thinking about the self-driving car. In particular, there is an analogy where if you look at so I have a Tesla, and if you look at the self-driving behavior of it, it looks like it does everything. It does everything.
All right.
But it's also clear that there is still a long way to go in terms of reliability. And we might be in a similar place with respect to our models where it also looks like we can do everything. And at the same time, we'll need to do some more work until we really iron out all the issues and make it really good and really reliable and robust and well-behaved.
By 2030, what % of GDP is AI?
Oh gosh, hard to answer that question. Very hard to answer that question.
Give me an over-under.
The problem is that my error bars are in log scale. So I could imagine a huge percentage. I could imagine a disappointingly small percentage at the same time.
Okay, so let's take the counterfactual where it is a small percentage. Let's say it's 2030 and not that much economic value has been created by these LLMs. As unlikely as you think this might be, what would be your best explanation right now of why something like this might happen?
My best explanation. So I really don't think that's a likely possibility.
Yeah.
So that's the preface to the comment. But if I were to take the premise of your question, why were things disappointing in terms of the real world impact? Then my answer would be reliability. If somehow it ends up being the case that you really want them to be reliable and they ended up not being reliable, or if reliability turned out to be harder than we expect, I really don't think that will be the case. But if I had to pick one and you tell me hey, why didn't things work out? It would be reliability, that you still have to look over the answers and double check everything. And that just really puts a damper on the economic value that can be
Got it.
produced by those systems.
That they'll be technologically mature. It's just a question of whether they'll be reliable enough.
Yeah, well, in some sense, not reliable means not technologically mature, if you see what I mean.
Yeah, fair enough. What's after generative models, right? So before you're working on reinforcement learning, is this basically it? Is this a paradigm that gets us to AGI, or is there something after this?
I mean, I think this paradigm is going to go really, really far, and I would not underestimate it. I think it's quite likely that this exact paradigm is not going to be quite the AGI form factor. I mean, I hesitate to say precisely what the next paradigm will be, but I think it will probably involve integration of all the different ideas that came in the past.
Is there some specific one you're referring to, or?
I mean, it's hard to be specific.
So you could argue that the next token prediction can only help us match human performance, and maybe not surpass it. What would it take to surpass human performance?
So I challenge the claim that next token prediction cannot surpass human performance. It looks like on the surface it cannot.
Mm-hmm.
It looks on the surface, if you just learn to imitate, to predict what people do, it means that you can only copy people. But here is a counter argument for why it might not be quite so if your base neural net is smart enough. You just ask it like, what would a person with great insight and wisdom and capability do? Maybe such a person doesn't exist, but there's a pretty good chance that the neural net will be able to extrapolate how such a person should behave. Do you see what I mean?
Yes, although where would it get the sort of insight about what that person would do, if not from
the data of regular people? Because if you think about it, what does it mean to predict the next token well enough? What does it mean actually? It's a deeper question than it seems. Predicting the next token well means that you understand the underlying reality that led to the creation of that token. It's not statistics, it is statistics, but what is statistics? In order to understand those statistics, to compress them, you need to understand what is it about the world that creates those statistics. And so then you say, okay, well, I have all those people. What is it about people that creates their behaviors? Well, they have, they have thoughts and they have feelings and they have ideas and they do things in certain ways. All of those would be deduced from next token prediction. And I'd argue that this should make it possible, not indefinitely, but to a pretty decent degree, to say, well, can you guess what you'd do if you took a person with this characteristic and that characteristic? Such a person doesn't exist. But because you're so good at predicting the next token, you should still be able to guess what that person would do, this hypothetical, imaginary person with far greater mental ability than the rest of us.
When we're doing reinforcement learning on these models, how long before most of the data for the reinforcement learning is coming from AIs and not humans?
I mean, already most of the data for reinforcement learning is coming from AIs. Yeah. Well, it's like the humans are being used to train the reward function, but then the reward function in its interaction with the model is automatic, and all the data that's generated during the process of reinforcement learning is created by AI. So if you look at the current, I would say, technique paradigm, which has been getting some significant attention because of ChatGPT, reinforcement learning from human feedback. So there is human feedback. The human feedback is being used to train the reward function. And then the reward function is being used to create the data which trains the model.
Got it. And is there any hope of just removing the human from the loop and have it improve itself and some sort of alpha go away?
Yeah, definitely. I mean, I feel in some sense our hopes for our plan, very much so. The thing you really want is for the human teachers that teach the AI, for them to collaborate with an AI. So you might want to think about it. You might want to think of it as being in a world where the human teachers do 1% of the world and the work, and the AI do 99% of the work. You don't want it to be 100% AI, but you do want it to be a human-machine collaboration, which teaches the next machine.
So currently, I've had the chance to play around these models. They seem bad at multi-step reasoning, and they have been getting better. But what does it take to really surpass that barrier?
I mean, I think dedicated training will get us there. More improvements to the base models will get us there.
Okay.
But fundamentally, I also don't feel they're that bad at multi-step reasoning. I actually think that they are bad at mental multi-step reasoning, but they're not allowed to think out loud. But when they are allowed to think out loud, they're quite good. And I expect this to improve significantly, both with better models and with special training.
Are you running out of reasoning tokens on the internet? Are there enough of them?
I mean, so for context on this question, like there are claims that indeed at some point we'll run out of tokens in general to train those models. And yeah, I think this will happen one day, and by the time that happens, we need to have other ways of training models, other ways of productively improving their capabilities and sharpening their behavior, making sure they're doing precisely what we want without more data.
You haven't run out of data yet? There's more?
Yeah, I would say the data situation is still quite good. There is still lots to go. But at some point data will run out.
Okay. What is the most valuable source of data? Is it Reddit, Twitter, books? What would you trade many other tokens of other varieties for?
Generally speaking, you'd like tokens which are, speaking about smarter things, tokens which are like more interesting.
Yeah.
So, I mean, all the sources which you mentioned, they're valuable.
Okay. So maybe not Twitter, but do we need to go multimodal to get more tokens, or do we still have enough text tokens left?
I mean, I think that you can still go very far in text only, but going multimodal seems like a very fruitful direction.
If you're comfortable talking about this, like where is the place where we haven't scraped the tokens yet?
Oh, I mean, yeah, obviously. I mean, I can't answer that question for us, but I'm sure that for everyone, there's a different answer to that question.
How many orders of magnitude improvement can we get just not from scale or not from data, but just from algorithmic improvements?
Hard to answer, but I'm sure there is some.
Is some a lot or is some a little?
I mean, it's only one way to find out.
Okay. Let me get to your quick fire opinions about these different research directions. Retrieval transformers. So just like somehow storing the data outside of the model itself and retrieving it somehow.
Seems promising.
But do you see that as a path forward, or?
I think it seems promising.
Robotics. Was it the right step for OpenAI to leave that behind?
Yeah, it was. Like back then, it really wasn't possible to continue working in robotics because there was so little data. Like back then, if you wanted to work on robotics, you needed to become a robotics company. You needed to really have a giant group of people working on building robots and maintaining them and even then, like if you're going to have 100 robots, it's a giant operation already, but you're not going to get that much data. So in a world where most of the progress comes from the combination of compute and data, right? That's where we've been, where it was the combination of compute and data that drove the progress. There was no path to data from robotics. So back in the day, when you made a decision to stop working in robotics, there was no path forward.
Is there one now?
So I'd say that now it is possible to create a path forward, but one needs to really commit to the task of robotics. You really need to say, I'm going to build like many thousands, tens of thousands, hundreds of thousands of robots and somehow collect data from them and find a gradual path where the robots are doing something slightly more useful. And then the data that they get from these robots, and then the data that is obtained and used to train the models, and they do something that's slightly more useful. So you could imagine this kind of gradual path of improvement where you build more robots, they do more things, you collect more data, and so on. But you really need to be committed to this path. If you say, I want to make robotics happen, that's what you need to do. I believe that there are companies who are thinking about doing exactly that. But I think that you need to really love robots and need to be really willing to solve all the physical and logistical problems of dealing with them. It's not the same as software at all. So I think one could make progress in robotics today with enough motivation.
What ideas are you excited to try, but you can't because they don't work well on current hardware?
I don't think current hardware is a limitation.
Okay.
I think it's just not the case.
Got it. So, but anything you want to try, you can just spin it up? Or?
I mean, of course. Like the thing, you might say, well, I wish current hardware was cheaper, or maybe it had higher, like maybe it would be better if it was higher memory processor bandwidth, let's say. But by and large, hardware is just a limitation.
Let's talk about alignment. Do you think we'll ever have a mathematical definition of alignment?
Mathematical definition, I think, is unlikely.
Uh-huh.
Like I do think that we will instead have multiple, like rather than achieving one mathematical definition, I think we'll achieve multiple definitions that look at alignment from different aspects. And I think that this is how we will get the assurance that we want. And by which I mean, you can look at the behavior. You can look at the behavior in various tests, in various adversarial stress situations. You can look at how the neural net operates from the inside. I think you could have to look at several of these factors at the same time.
And how sure do you have to be before you release a model in the wild? Is it 100%, 95%?
Well, it depends how capable the model is. The more capable the model is, the higher the more confident you need to be.
Okay, so just say it's something that's almost AGI. Where is AGI?
Well, it depends what your AGI can do. Keep in mind that AGI is an ambiguous term also.
Yeah.
Like your average college undergrad is an AGI, right?
It's debatable, yeah.
But you see what I mean. There's significant ambiguity in terms of what is meant by AGI.
Mm-hmm.
And so depending on where you put this mark, you need to be more or less confident.
Well, you mentioned a few of the paths towards alignment earlier. What is the one you think is most promising at this point?
Like, I think that it will be a combination. I really think that you will not want to have just one approach.
Mm-hmm.
I think people want to have a combination of approaches where you spend a lot of compute to adversarially probe it to find any mismatch between the behavior that you wanted to teach and the behavior that it exhibits. We look inside into the neural net using another neural net to understand how it operates on the inside. I think all of them will be necessary. Every approach like this reduces the probability of misalignment. And you also want to be in a world where your degree of alignment keeps on increasing faster than the capability of the models. I would say that right now, our understanding of our models is still quite rudimentary. We made some progress, but much more progress is possible. And so I would expect that ultimately the thing that will really succeed is when we will have a small neural net that is well understood, that's given the task to study the behavior of a large neural net that is not understood, to verify it.
By what point is most of the AI research being done by AI?
I mean, so today when you use Copilot, right? What fraction? How do you divide it up? So I expect at some point you ask your, descendant of ChatGPT, you say, hey, like I'm thinking about this and this. Can you suggest fruitful ideas I should try? And you would actually get fruitful ideas.
Mm-hmm.
Right? And I think that will make it possible for you to solve problems you couldn't solve before.
Got it. But it's somehow just telling the humans, giving them ideas faster or something. It's not itself interacting with the...
One example. I mean, you could slice it in a variety of ways. But I think the bottleneck there is good ideas, good insights. And that's something which the neural nets could help us with.
Mm-hmm. If you could design like $1 billion prize for some sort of alignment research result or product, what is like the concrete criterion you would set for that $1 billion prize? Is there something that makes sense for such a prize?
It's funny that you asked this. I was actually thinking about this exact question. I haven't come up with an exact criterion yet. Maybe something that with the benefit, like maybe a prize where we could say that 2 years later or 3 years or 5 years later, we'll look back and say like that was the main result. So rather than say that there is a prize committee that decides right away, we wait for 5 years and then award it retroactively.
But there's no concrete thing we can identify yet as like you solved this particular problem and you made a lot of progress.
I think a lot of progress, yes. I wouldn't say that would be the full thing.
Mm-hmm. Do you think end-to-end training is the right architecture for bigger and bigger models, or do we need better ways of just connecting things together?
I think end-to-end training is very promising. I think connecting things together is very promising.
Everything is promising. So OpenAI is projecting revenues of $1 billion in 2024. That might very well be correct, but I'm just curious, when you're talking about a new general purpose technology, how do you estimate how big a windfall it'll be? Like, why that particular number?
I mean, we've already had we've had a product for quite a while now, back from the GPT-3 days, from 2 years ago through the API, and we've seen how it grew. We've seen how the response to DALL-E has grown as well. And so you see how the response to ChatGPT is. And I think all of this gives us information that allows us to make a relatively sensible extrapolation to 2024. Maybe that would be one answer. Like, you need to have data. You can't come up with those things out of thin air, because otherwise your error bars will be like your error bars are going to be like 100x in each direction.
Let's talk about what like a post-AGI future looks like. So are people like you know, I'm guessing you're working like 80-hour weeks towards this grand goal that you're really obsessed with. Are you going to be satisfied in a world where you're basically living in an AI retirement home? Or like, what is the word? What is like what are you concretely doing after AGI comes?
I think the question of what I'll be doing or what people will be doing after AGI comes is a very tricky question. You know, I think where will people find meaning? But I think that that's something that AI could help us with. Like, one thing I imagine is that we'll all be able to become more enlightened because we'd interact with an AGI that will help us see the world more correctly, or become better on the inside as a result of interacting. Like, imagine talking to the best meditation teacher in history. I think that will be a helpful thing. But I also think that because the world will change a lot, it will be very hard for people to understand what is happening precisely and how to really contribute. One thing that I think some people will choose to do is to become part AI in order to really expand their minds and understanding and to really be able to solve the hardest problems that society will face then.
Are you going to become part of AI?
Very tempting. It is tempting, yeah.
Well, do you think there'll be physically embodied humans in 3000?
3,000. Oh, how do I know what's going to happen in 3,000?
Like, what does it look like? Are there still like humans walking around on Earth, or have you guys thought concretely about what you actually want this world to look like?
3,000. Well, I mean, that the thing is, here's the thing. Like, let me describe to you what I think is not quite right about the question. Like, it implies like, oh, like we get to decide how we want the world to look like. I don't think that picture is correct. I think change is the only constant. And so, of course, even after AGI is built, it doesn't mean that the world will be static. The world will continue to change. The world will continue to evolve. And it will go through all kinds of transformations. And I don't think anyone has any idea of how the world will look like in 3000. But I do hope that there will be a lot of descendants of human beings who will live happy, fulfilled lives where they're free to do as they wish, as they see fit, where they are the ones who are solving their own problems. Like, one of the things which I would not want, one world which I would find very unexciting is one where, you know, we build this powerful tool and then the government said, okay, so the AGI said that society shall be run in such a way, and now we shall run society in such a way. I'd much rather have a world where people are still free to make their own mistakes and suffer their consequences and gradually evolve morally and progress forward on their own through their own strength. See what I mean? With the AGI providing more like a base safety net.
How much time do you spend thinking about these kinds of things versus just doing the research that?
I do think about those things a fair bit, yeah. I think those are very interesting questions.
So in what ways have the capabilities we have today, in what ways have they surpassed where you expected them to be in 2015? And in what ways are they still not where you would have expected them to be by this point?
I mean, in fairness, they did surpass what I expected them to be in 2015. In 2015, my thinking was a lot more, I just don't want to bet against deep learning. I want to make the biggest possible bet on deep learning. Don't know how, but it will figure it out.
But is there any specific way in which it's been more than you expected or less than you expected? Like some concrete prediction you had in 2015 that's been trounced?
You know, unfortunately, I don't remember concrete predictions I made in 2015. But I definitely think that overall, in 2015, I just wanted to move, to make the biggest bet possible on deep learning. But I didn't know exactly. I didn't have a specific idea of how far things will go in 7 years. Well, I mean, 2015, I did have all these bets with people in 2016, maybe 2017, that things will go really far. But specifics. So it's like, it's both the case that it surprised me, and I was making these aggressive predictions, but I think maybe I believe them only 50% on the inside.
Well, what do you believe now that even most people at OpenAI would find far-fetched?
I mean, I think that because we communicate a lot at OpenAI, people have a pretty good sense of what I think. And so, yeah, we reached the point at OpenAI where I think we see eye to eye on all these questions.
So Google has, its custom TPU hardware. It has all this data from all its users, Gmail, and so on. Does it give it an advantage in terms of training bigger models and better models than you?
So I think like when the TPU came out, I was really impressed and I thought, wow, this is amazing. But that's because I didn't quite understand hardware back then. What really turned out to be the case is that TPUs and GPUs are almost the same thing. They are very, very similar. It's like, I think a GPU chip is a little bit bigger. I think a TPU chip is a little bit smaller. It may be a little bit cheaper, but then they make more GPUs than TPUs. So I think the GPUs might be cheaper after all. But fundamentally, you have a big processor and you have a lot of memory, and there is a bottleneck between those two. And the problem that both the TPU and the GPU are trying to solve is that by the amount of time it takes you to move one floating point from the memory to the processor, you can do several hundred floating point operations on the processor, which means that you have to do some kind of batch processing. And in this sense, both of these architectures are the same. So I really feel like hardware, like in some sense, the only thing that matters about hardware is cost per flop, overall systems cost.
Okay, and there isn't that much difference.
Well, I actually don't know. I mean, I don't know how much, what the TPU costs are, but I would suspect that probably not. If anything, probably the TPUs are more expensive because there is less of them.
When you're doing your work, how much of the time is spent, configuring the right initializations, making sure the training run goes well and getting the right hyperparameters, and how much is it just coming up with whole new ideas?
I would say it's a combination, but I think that coming up with, it's a combination. But coming up with whole new ideas is actually not, it's like a modest part of the work. Certainly coming up with new ideas is important. But I think even more important is to understand the results, to understand the existing ideas, to understand what's going on. Because normally you have these, a neural net is a very complicated system, right? And you ran it and you get some behavior which is hard to understand what's going on. Understanding the results, figuring out what next experiment to run. A lot of the time is spent on that. Understanding what could be wrong, what could have caused the neural net to produce a result which was not expected. I'd say a lot of time is spent as well. Of course, coming up with new ideas, but not new ideas. I think like, I don't like this framing as much. It's not that it's false, but I think the main activity is actually understanding.
What do you see as the difference between the two?
So at least in my mind, when you say come up with new ideas, I'm like, oh, like what happened if we did such and such? Whereas understanding, it's more like what is this whole thing? Like, what are the real underlying phenomena that are going on? What are the underlying effects? Like, why are we doing things this way and not another way? And of course, this is very adjacent to what can be described as coming up with ideas. But I think the understanding part is where the real action takes place.
Does that describe your entire career? Like if you think back on like ImageNet or something, was that more new idea or was that more understanding?
Oh, I was definitely understanding. Definitely understanding. It was a new understanding of very old things.
But what is the experience of training on Azure been like, using Azure?
Fantastic. Microsoft has been a very, very good partner for us, and they've really helped take Azure and bring it to a point where it's really good for ML. And we're super happy with it.
How vulnerable is the whole AI ecosystem to something that might happen in Taiwan? So let's say there's like a tsunami in Taiwan or something. What happens to AI in general?
Like it's definitely going to be a significant setback. It's not going to, like, it might be something equivalent to, like, no one will be able to get more compute for a few years. But I expect compute will spring up. Like, for example, I believe that Intel has fabs just of like a few generations ago. So that means that if Intel wanted to, they could produce something GPU-like from like 4 years ago. So yeah, it's not the best, let's say. I'm actually not sure about if my statement about Intel is correct, but I do know that there are fabs outside of Taiwan that is not as good. But you can still use them and still go very far with them. It's just a setback.
Will inference get cost prohibitive as these models get bigger and bigger?
So I have a different way of looking at this question.
Yeah.
It's not that inference will become cost prohibitive. Inference of better models will indeed become more expensive. But is it prohibitive? Well, it depends on how useful is it. Like if it is more useful than it is expensive, then it is not prohibitive. Like to give you an analogy, like suppose you want to talk to a lawyer, you have some case or need some advice or something. You are perfectly happy to spend $500 an hour, right? So if your neural net could give you like really reliable legal advice, you'd say, I'm happy to spend $400 for that advice. And suddenly inference becomes very much non-prohibitive. The question is can neural net produce an answer good enough at this cost?
Yes. And you will just have like price discrimination, different
Yeah,
different models of
Well,
different
I
levels?
mean, it's already the case today. So on our product, the API, we serve multiple neural nets of different sizes, and different customers use different neural nets of different sizes depending on their use case. Like if someone can take a small model and fine tune it and get something that's satisfactory for them, they'll use that.
Yeah.
But if someone wants to do something more complicated and more interesting, they'll use the biggest model.
How do you prevent these models from just becoming commodities where these different companies just they just bid each other's prices down until it's basically the cost of the GPU run?
Yeah, I think there is without question a force that's trying to create that. And the answer is you got to keep on making progress. You got to keep improving the models. You got to keep on coming up with new ideas and making our models better and more reliable, more trustworthy, so you can trust their answers. All those things.
Yeah, but let's say it's like 2025 and the model from 2024, somebody just offering it at cost and it's like still pretty good. Why would people use a new one from 2025 if the one from just a year older is, cheap and better?
So there are several answers there. For some use cases, that may be true. There will be a new model from 2025, which will be driving the more interesting use cases. There's also going to be a question of inference cost. Like you can do research to serve the same model at less cost. So there will be the same model will be served, will cost different amounts to serve for different companies. I can also imagine some degree of specialization too, where some companies may try to specialize in some area and be stronger in a narrower area compared to other companies. And I think that too may be a response to commoditization to some degree.
As over time, do these different companies, do their research directions converge or they diverge? Are they doing similar things over time, or are they going off, branching off into different areas?
So I'd say in the near term, it looks like there is convergence. I expect there's going to be a convergence, a divergence convergence behavior, where there is a lot of convergence on the near term work. There's going to be some divergence on the longer term work. But then once the longer term work starts to yield fruit, I think there will be convergence again.
Got it. When one of them finds the most promising area, everybody just...
That's right. Now, there is obviously less publishing now, so it will take longer before this promising direction gets rediscovered. But that's how I'd imagine it. I think it's going to be convergence, divergence, convergence.
Yeah. We talked about this a little bit at the beginning, but as foreign governments learn about how capable these models are, are you worried about spies or some sort of attack to get your weights or, somehow abuse these models and learn about them?
Yeah, it's definitely something that you absolutely can't discount that.
Yeah.
And yeah, something that we try to guard against the best of our ability, but it's going to be a problem for everyone who's building this.
How do you prevent your weights from leaking?
I mean, you have really good security people.
And how many people have if they wanted to just SSH into the weights, how many people could do that?
I mean, what I can say is that the security people that we have, they've done a really good job, so that I'm really not worried about the weights being leaked.
Okay, got it. What kinds of emergent properties are you expecting from these models at this scale? Is there something that just comes about de novo?
I'm sure things will come. I'm sure really new surprising properties will come up. I would not be surprised. The thing which I'm really excited about, or the thing which I'd like to see, is reliability and controllability. I think that this will be very, very important class of emergent properties. If you have reliability and controllability, I think that helps you solve a lot of problems. Reliability means you can trust the model's output. Controllability means you can control it. And we'll see. But it will be very cool if those emergent properties did exist.
Is there some way you can predict it in advance? What will happen in this parameter count? What will happen in that parameter count?
I think it's possible to make some predictions about specific capabilities, though it's definitely not simple and you can't do it in a super fine-grained way, at least today. But I think getting better at that is really important. And anyone who is interested in, who has research ideas on how to do that, I think that can be a valuable contribution.
How seriously do you take these scaling laws? If there's a paper that says you just you need this many orders of magnitude more to get all the reasoning out. Do you take that seriously, or do you think it breaks down at some point?
Well, the thing is that the scaling law tells you what happens to your next word prediction accuracy, right? There is a whole separate challenge of linking next word prediction accuracy to reasoning capability. I do believe that indeed there is a link, but this link is complicated. And we may find that there are other things that can give us more reasoning per unit effort. like, for example, some special, like, you mentioned reasoning tokens, and I think they can be helpful. There can be probably some things that do.
Is something you're considering just hiring humans to generate tokens for you, or is it all going to come from stuff that already exists out there?
I mean, I think that relying on people to teach our models to do things, especially, to make sure that they are well behaved and they don't produce false things, I think is an extremely sensible thing to do. And
Isn't it odd that we have the data we need at exactly the same time as we have the transformer at the exact same time that we have these GPUs? Like, is it odd to you that all these things happen at the same time, or do you not see it that way?
I mean, it is definitely an interesting situation that is the case. I will say that it is odd, and it is less odd on some level. Here is why it's less odd. So what is the driving force behind the fact that the data exists, that the GPUs exist, that the transformer exists? So the data exists because computers became better and cheaper. We've got smaller and smaller transistors. And suddenly at some point it became economical for every person to have a personal computer. Once everyone has a personal computer, you really want to connect them with the network. You get the internet. Once you have the internet, you have suddenly data appearing in great quantities. The GPUs were improving concurrently because you have smaller and smaller transistors and you're looking for things to do with them. Gaming turned out to be a thing that you could do. And then at some point, the gaming GPU, NVIDIA said, wait a sec, Ryan, may turn it into a general purpose GPU computer. Maybe someone will find it useful. Turns out it's good for neural nets. So it could have been the case that maybe the GPU would have arrived 5 years later or 10 years later. Let's suppose gaming wasn't a thing. It's kind of hard to imagine. What does it mean if gaming isn't a thing? But maybe there was a counterfactual world where GPUs arrived 5 years after the data or 5 years before the data. In which case, maybe things would move a little bit more. Things would have been as ready to go as they are now. But that's the picture which I imagine. All this progress in all these dimensions is very intertwined. It's not a coincidence that, like, you don't get to pick and choose in which dimensions things improve, if you see what I mean.
How inevitable is this kind of progress? So if, like, let's say you and Jeffrey Hinton and a few other pioneers, if they were never born, does the deep learning revolution happen around the same time? How much does it delay?
I think maybe there would have been some delay, maybe like a year delay. It's really hard to tell.
That's it?
It's really hard to tell. I mean, I hesitate to give a longer answer because, okay, well, then you'd have GPUs would keep on improving, right? Then at some point, I cannot see how someone would not have discovered it. Because here's the other thing. Okay, so let's suppose no one has done it. Computers keep getting faster and better. It becomes easier and easier to train these neural nets because you have bigger GPUs. So it takes less engineering effort to train one. You don't need to optimize your code as much. When the ImageNet dataset came out, it was huge and it was very, very difficult to use. Now imagine you wait for a few years and it becomes very easy to download and people can just tinker. So I would imagine that, like, a modest number of years maximum. This would be my guess. I hesitate to give a longer answer, though. You can't rerun the world. You don't know.
Let's go back to alignment for a second. As somebody who deeply understands these models, what is your intuition of how hard alignment will be?
Like, I think so here's what I would say. I think with the current level of capabilities, I think we have a pretty good set of ideas of how to align them. But I would not underestimate the difficulty of alignment of models that are actually smarter than us, of models that are capable of misrepresenting their intentions. Like, I think it's something to think about a lot and to research. I think this is one area also, by the way. Like, oftentimes academic researchers ask me what's the best place where they can contribute. And I think alignment research is one place where I think academic researchers can make very meaningful contributions.
Other than that, do you think academia will come up with important insights about actual capabilities, or is that going to be just the companies at this point?
So the companies will realize the capabilities. I think it's very possible for academic research to come up with those insights. I think it doesn't seem to happen that much for some reason, but I don't think there's anything fundamental about academia. Like, it's not like academia can't. I think maybe they're just not thinking about the right problems or something, because maybe it's just easier to see what needs to be done inside these companies.
I see. But there's a possibility that somebody could just realize
Yeah, I totally think so. Like, why would I possibly rule this out?
Yeah,
You see
yeah,
what I mean?
yeah. What are the concrete steps by which these language models start actually impacting the world of atoms and not just the world of bits?
Well, you see, I don't think that there is a clean distinction between the world of bits and the world of atoms. Suppose the neural net tells you that, hey, like here is like something that you should do and it's going to improve your life, but you need to like rearrange your apartment in a certain way. And you go and you rearrange your apartment as a result. Did the neural net impact the world of atoms? Just
Yeah, fair enough. Fair enough. Do you think it'll take a couple of additional breakthroughs as important as the transformer to get to superhuman AI? Or do you think we basically got the insights in the books somewhere and we just need to implement them and connect them?
so I don't really see such a big distinction between those two cases, and let me explain why. Like I think what one of the ways in which progress has taken place in the past is that we've understood that something had a property, a desirable property all along, which we didn't realize. So is that a breakthrough? You can say, yes, it is. Is that an implementation of something on the books? Also, yes. So my feeling is that a few of those are quite likely to happen, but that in hindsight, it will not feel like a breakthrough. Everybody's going to say, oh, well, of course, like it's totally obvious that such and such thing can work. You see, with the transformer, the reason it's being brought up as a specific advance is because it's the kind of thing that was not obvious for almost anyone. So people can say, yeah, like it's not something which they knew about. But if an advance comes from something, like let's consider that the most fundamental advance of deep learning, that a big neural network trained with backpropagation can do a lot of things. Like, where's the novelty? It's not in the neural network. It's not in the backpropagation. But then somehow it's the kind of, but it is most definitely a giant conceptual breakthrough because for the longest time, people just didn't see that. But then now that everyone sees it, everyone's going to say, well, of course, like it's totally obvious. Big neural network. Everyone knows that they can do it.
What is your opinion of your former advisor's new forward algorithm?
I think that it's an attempt to train a neural network without backpropagation. And I think that this is especially interesting if you are motivated to try to understand how the brain might be learning its connections. The reason for that is that, as far as I know, neuroscientists are really convinced that the brain cannot implement backpropagation because the signals in the synapses only move in one direction. And so if you have a neuroscience motivation and you want to say, okay, how can I come up with something that tries to approximate the good properties of backpropagation without doing backpropagation? That's what the forward algorithm is trying to do. But if you are trying to just engineer a good system, there is no reason to not use backpropagation. Like, it's the only algorithm really.
Mm. I guess I've heard you in different contexts talk about the need, like using humans as the existing example case that, AGI exists, right? So at what point do you take the metaphor less seriously and don't feel the need to pursue it in terms of the research? Because it is important to you as a sort of existence case.
Like, at what point do I stop caring about humans as an existence case of intelligence?
Or as the sort of, as an example of the model you want to follow in terms of pursuing intelligence in models.
I see. I mean, like I think it's good to be inspired by humans. I think it's good to be inspired by the brain. I think there is an art into being inspired by humans and the brain correctly, because it's very easy to latch on to a non-essential quality of humans or of the brain. And I think many people whose research is trying to be inspired by humans and by the brain often gets a little bit specific. People get a little bit too, okay, so like what cognitive science model should we follow? At the same time, consider the idea of the neural network itself, the idea of the artificial neuron. This too is inspired by the brain, but it turned out to be extremely fruitful. So how do you do this? What behaviors of human beings are essential that you say, like, this is something that proves to us that it's possible? What is inessential? No, actually, this is like some emergent phenomena of something more basic, and we just need to focus on getting our own basics right. I would say that it's like, I think one can and should be inspired by human intelligence with care.
Final question. Why is there, in your case, such a strong correlation between being first to the deep learning revolution and still being one of the top researchers? You would think that these two things wouldn't be that correlated, but why is that correlation?
I don't think those things are super correlated indeed. I feel like in my case, I mean, honestly, it's hard to answer the question. I just kept trying really hard, and it turned out to have sufficed thus far.
Got it. So it's a perseverance.
I think it's a necessary but not a sufficient condition. Like, many things need to come together in order to really figure something out.
Mm-hmm.
Like you need to really go for it, and also need to have the right way of looking at things. And so it's hard to give him like a really meaningful answer to this question.
Got it. Ilya, it has been a true pleasure. Thank you so much for coming on the Lunar Society. I appreciate you bringing us to the offices. So thank you.
Yeah, I really enjoyed it. Thank you very much.